This is your need to know. This is your need to know.
Welcome to the deep dive. We're going deep today into some pretty complex stuff.
Yeah.
Chaos theory, sudden system shifts,
Right.
and even a bit of cryptography.
Cool.
All of this because it connects back to
Okay.
some materials that you actually shared with us.
Sure.
So are you ready to have your mind blown?
I think so. It's really fascinating stuff.
Yeah.
You know, we're going to be looking at
Yeah.
systems that seem totally random on the surface,
Right.
but then underneath that,
Oh, yeah.
you know, that apparent randomness,
Uh,
there's this hidden order.
I love that.
Yeah.
This hidden order and chaos.
Yeah.
That actually reminds me of something from
Okay.
that Wikipedia article you sent over on chaos theory.
Right.
It talks about how these chaotic systems can be predictable,
Yeah.
but only for a certain amount of time.
Uh-huh.
It's like how weather forecasts,
Right.
they can be pretty accurate for a few days out,
Uh-huh.
but then the further out you go,
Yeah.
it's really anyone's guess. Is that what we're talking about here?
Exactly. That's what we're talking about.
Okay, cool.
That window of predictability,
Yeah.
you know, before things get really chaotic,
Okay.
is determined by
Okay.
a few different factors.
Okay.
One of the big ones is something called
Okay.
the Lyapunov time,
Okay.
which basically measures
Yeah.
how sensitive a system is
Okay.
to its initial conditions.
Got it.
So think about it like this.
Okay.
Even something as small
Yeah.
as a butterfly flapping its wings
Right.
could eventually lead to a massive storm
Oh, wow.
halfway across the world.
Okay.
That's the famous butterfly effect.
Right, the butterfly effect.
Yeah.
Okay, so you're saying even if we could measure everything perfectly,
Yeah.
there's still a limit
Yes.
to how far we can predict into the future,
Uh-huh.
and that even the tiniest error
Yeah.
can throw everything off.
That's right. That's the wild part about chaotic systems.
Wow.
There's always going to be some level of uncertainty.
Right.
And that uncertainty,
Yeah.
it grows exponentially over time.
Right.
It's like trying to predict where a pinball will go,
Uh-huh.
even with a perfect machine.
Yeah.
The slightest bump can send it on a completely different path.
Wow. Okay, so this is already blowing my mind.
Yeah.
But it gets even more interesting.
Okay.
You also sent over this document
Uh-huh.
called 2016-468.pdf,
Right.
which talks about something called a chaos machine.
Yeah.
And it seems like it uses chaos theory
Uh-huh.
to create a whole new type of cryptography.
Right.
Have you ever heard of anything like this before?
The chaos machine it's definitely a fascinating concept.
Okay.
It's basically a theoretical model
Mhm.
that uses the unique properties of these chaotic systems
Right.
to strengthen encryption.
Okay.
The author,
Yeah.
Maciej Krzyzewski,
Yeah.
thinks we could use this machine to build all sorts of cryptographic tools,
Like what?
like hash functions,
Uh-huh.
message authentication codes, even random number generators.
Whoa.
Instead of relying on
Yeah.
those complex math equations,
Right.
we'd be using the natural randomness of chaotic systems
Okay.
to generate secure keys and encrypt data.
Hold on.
Yeah.
So you're telling me that this chaos machine could potentially make
Yeah.
our online data more secure?
That's the idea.
That's huge, especially with
Especially these days.
all the hacking and data breaches happening these days.
It's a big deal.
So how does it even work?
So,
Is it like a one-way street
Right.
where
Yeah.
it's easy to go forward but almost impossible to go back
you got it.
without the right key?
That's a great analogy.
Okay.
The chaos machine works on the principle of diffusion,
Diffusion.
meaning even a tiny difference in the input
Oh,
can lead to a huge change in the output.
Okay.
And this makes it extremely difficult
Yeah.
for hackers to reverse engineer the process
Right.
and crack the code.
Got it.
It does this while also being deterministic,
Determine.
meaning that the output seems random.
Okay.
It can be perfectly recreated
Yeah.
if you have the initial conditions
Yeah.
and the rules of the system.
Okay. So it's
Yeah.
like having a secret recipe
Exactly.
that only,
Uh-huh.
and even if someone saw the final dish,
Yeah.
they couldn't figure out the ingredients or how to make it.
Exactly.
That's so clever.
That's a cool idea.
So if I'm getting this right,
Yeah.
this chaos machine takes something unpredictable, like
Mhm.
weather patterns or a pinball bouncing around,
Right.
and uses that unpredictability to create something predictable.
That's right.
and secure,
Yeah,
like a cryptographic key.
you got it.
Okay.
The document even includes a basic implementation of the chaos machine,
Uh-huh. Like, what do they call it?
the naive Shizevsky generator,
Okay.
or NCG.
NCG, got it.
And it actually passed
What
a
about-
bunch of statistical randomness tests.
Like what?
Tests like Die Harder, NIST, and Test U1.
That's impressive.
Yeah, pretty impressive.
That's really impressive. It sounds like
Yeah,
this could be a game changer
potentially.
for cybersecurity.
Yeah, for sure.
But let's switch gears for a minute.
Okay.
You also included some materials
Uh-huh.
on catastrophe theory.
Right.
The Wikipedia article you sent over was really interesting.
Yeah.
It mentioned something called a tipping point,
Yeah,
which sounds pretty intense.
it is pretty intense.
Can you tell me more about that?
Absolutely.
Okay.
Catastrophe theory focuses on
Okay.
those big, sudden changes
Uh-huh.
that can happen in a system.
Okay.
It's all about how things can
Mhm.
rapidly shift from one state to another.
Okay.
Think about a rubber band.
Okay.
You can stretch it further and further.
Yeah.
It seems fine.
Uh-huh.
But then you reach a point where it suddenly snaps.
Right.
That's a tipping point.
Okay. So that's the tipping point.
When a system can't take the pressure anymore
Right.
and it abruptly changes its behavior.
Okay. So are you saying that these tipping points could be happening
They could be happening.
all around us
Yeah,
in systems big and small,
that's right.
like in the environment,
Yeah.
in our economy,
Yeah,
even in our personal lives?
that's right.
Wow.
Think about a population of animals.
Okay.
As long as they have enough food and space,
Yeah.
their numbers might stay stable.
Right.
But if something changes,
Okay.
like say a drought hits
Huh?
or a new predator arrives,
Oh.
their population
Yeah.
could hit a tipping point
Yeah.
and suddenly crash.
Wow. That's powerful.
Catastrophe theory helps us understand these dramatic shifts
Okay.
and what might trigger them.
Wow. That's a pretty powerful example.
Yeah.
It makes you think about all the potential tipping points
Uh-huh.
we might be facing
Yeah,
with climate change
Yeah.
and other global challenges.
for sure.
This deep dive is really making me think.
Me too.
But before we move on, can you remind me what were the key takeaways about chaotic systems themselves?
Yeah, so we talked about how chaotic systems are deterministic,
Okay.
but still unpredictable
Right.
beyond their Lyapunov time,
Uh-huh.
which is a measure of how quickly those errors grow.
Right.
So they are predictable in the short term,
Okay.
but unpredictable in the long term.
Got it.
We also touched on the fact that
Yeah.
the systems have an infinite number
Okay.
of unstable periodic orbits
Uh-huh.
within their chaotic attractors.
Okay.
This is actually really important
Okay.
when it comes to controlling chaos,
Okay.
which we can dive into more later.
Okay. This is already so much to take in.
It's a lot.
I'm definitely ready to keep exploring.
Awesome. Let's do it.
We've got a lot more ground to cover in part 2.
We do. So what's really cool
Yeah.
is that chaos theory
Mhm.
isn't just stuck,
Yeah.
in the world of math equations and stuff.
Right.
It's actually being used
Wow.
in tons of different fields.
Like things like physics and engineering,
Yeah.
biology,
Okay.
even economics.
Wow. So it's not just theoretical.
No.
This chaos stuff is
Yeah.
actually having a real world impact.
Absolutely.
Okay, I'm all ears.
So, for instance,
Okay.
in physics,
Yeah.
chaos theory is helping us understand things like
Okay.
turbulence in fluids
Uh-huh.
and the way chaotic pendulums move.
Okay.
And get this,
Yeah.
it's even being used
What?
to study how celestial bodies move
Oh, wow.
in something called the three-body problem.
Wait, the three-body problem?
Yeah.
That rings a bell.
Uh-huh.
I think I vaguely remember that from
Oh.
physics class.
Yeah, you probably learned about it in school.
It was a long time ago.
Right.
Remind me what that's all about.
So basically, it
Uh-huh.
describes how three celestial objects,
Okay.
like planets or stars,
Uh-huh.
move under each other's gravity.
Okay.
And the crazy thing is,
Yeah.
even though gravity is a pretty simple force,
Predicting the long-term movement of these objects
Yeah.
is super complex,
Yeah.
even chaotic.
so even with all of our fancy telescopes and computers,
Yeah.
we still can't perfectly predict where planets will be
It's much, much harder.
millions of years from now.
Yeah, it's much harder
Yeah.
than predicting the motion of just two bodies
Right.
where things are neat and predictable.
Okay.
The three-body problem shows us that even simple systems
Okay.
can become incredibly complex
Uh-huh.
and unpredictable over time.
Wow.
It took some of the brightest minds
Yeah.
centuries to even begin to understand this problem.
Wow, that's incredible.
Yeah.
It really shows you how unpredictable the universe can be.
Yeah.
But you also mentioned that chaos theory is being applied to other fields,
Yeah.
like biology.
Yeah, like a biology.
I'm having trouble wrapping my head around that.
Yeah.
How chaos would apply to living things.
Well,
Yeah.
biological systems are incredibly complex. We're talking about countless variables
Okay.
all interacting with each other.
Right.
Chaos theory helps us make sense of this complexity.
Okay.
For example,
Yeah.
scientists are using it
Okay.
to model things like population dynamics,
Uh-huh.
the spread of diseases,
Okay.
even the electrical activity of the heart,
Wow.
which can seem random,
Yeah.
but actually follows specific patterns.
That's amazing to think that
Yeah.
chaos theory could help us unlock
Yeah.
some of the mysteries of life itself.
Potentially.
It really highlights
Yeah.
how much we still don't know
Right.
about the world around us.
Yeah.
Even the systems that we think we understand pretty well.
Absolutely.
This is really making me think.
Good.
But I have a question.
Okay.
If chaotic systems
Yeah.
are so unpredictable,
Right.
how can scientists even try to control them?
That's a great question.
Is that even possible?
It might sound counterintuitive,
Yeah.
but yes,
Well,
we can actually control chaos. Okay. One of the key methods is called the Ott-Grabo-Bjork method,
Okay.
or OGY for short.
OGY got it.
You sent over a great document
Yeah.
called physicsreport.pdf
Right?
that dives deep into this.
Yeah, that document talks about
Uh,
how scientists can use tiny, well-timed nudges
Yeah.
to push a chaotic system
Uh-huh.
towards a more stable and predictable state.
That's right.
Kind of like steering a boat
Exactly.
through choppy waters.
That's a great analogy.
Okay.
You're not trying to fight the waves head on. Instead, you make small adjustments
Yeah.
to stay on course.
Okay.
And that's the key with controlling chaos.
Got it.
Making subtle adjustments
Right.
to guide the system
Uh-huh.
toward a desired outcome.
That makes a lot of sense.
Yeah.
The document also mentioned something
It did.
called chaotic saddles.
Yes.
Do you remember those?
Of course.
They sounded pretty wild.
They are pretty wild.
Can you refresh my memory
Yeah.
on what those are all about?
So chaotic saddles are fascinating.
Okay.
Imagine you're exploring a chaotic system
Huh.
where things are constantly in flux.
Okay.
There are regions in this system
Yeah.
where the dynamics are super unstable.
Right.
Any slight change
Yeah.
can send things spiraling away.
Okay.
Chaotic saddles are like
Yeah.
unstable equilibrium points
Right.
within this chaotic sea.
Okay.
They help us understand how things escape
Okay.
from certain regions of the chaotic attractor.
Okay.
It's like those escape hatches
Yeah. The escape hatches.
that we talked about earlier.
Right. So they're like points of no return
Right.
in a chaotic system.
It's not quite that simple,
Okay.
but they are important
Okay.
for understanding
Yeah.
how long a trajectory
Okay.
can remain within a specific region of the system
Uh-huh.
before eventually escaping.
Okay.
And here's the really cool part.
Okay. What's that?
Chaotic saddles are remarkably resilient to noise,
Okay.
which means they could be really useful
For what?
for building super robust communication technologies.
Hold on. So you're telling me
Yeah.
we can actually use these chaotic saddles
To
our
our
advantage, that chaos can actually help us build more reliable systems,
That's exactly right.
even in really unpredictable environments.
And then in really unpredictable environments.
That's amazing.
The physicsreport.pdf document also talks about
Okay.
how chaotic saddles can help us design
Okay.
more efficient ways to control chaotic systems
Right.
by targeting the areas
Yeah.
where things are most sensitive.
Okay.
And get this,
Yeah.
the principles of chaos control
Yeah.
aren't just theoretical.
But
Scientists have already used them in the real world
to
to stabilize lasers,
Uh-huh.
electronic circuits, even influence how chemical reactions occur.
That's incredible.
Yeah, it's pretty amazing.
And it really makes you wonder,
It does.
what other applications are just waiting to be discovered?
Yeah, that's the beauty of science.
Yeah.
There's always more to explore.
Right.
And chaos theory reminds us
Yeah.
that even in the face of apparent randomness, there's an underlying order
I love that.
just waiting to be understood.
My head is spinning.
I know, it's a lot.
With all this new information,
Yeah.
this deep dive is turning out to be even more enlightening
Good.
than I could have imagined.
I'm glad to hear that.
But before we get too lost in the chaos,
Okay.
can we recap the key points
Sure.
from this part?
Of course.
I want to make sure I'm retaining all of this.
So we explored how
Yeah.
chaos theory is making waves in all sorts of fields, from explaining the mind-boggling movements
Yeah.
of celestial objects in the three-body problem
Right.
to modeling the intricate inner workings of living things.
Okay.
We also dove into
Yeah.
the fascinating concept of controlling chaos,
Right.
using techniques like the OGY method, which allows us to nudge these wild systems toward a more stable state.
Right. Okay. I think I'm starting to get a handle on this chaos thing.
Good.
I'm super curious to see what else we uncover in part 3.
I can't wait to share it with you.
Okay, so we've covered a lot of ground already.
We have.
From the basics of chaos theory
Right.
to this mind-blowing idea
Yeah.
of actually controlling
Yeah.
those chaotic systems.
Uh-huh.
But you mentioned at the beginning
You did.
that all of this ties back
Yeah.
to cryptography and communication.
Yeah.
I have to admit, I'm finding it hard to connect the dots.
Okay.
Chaos and communication
Yeah.
seem like polar opposites to me.
It does seem a bit counterintuitive, doesn't it?
Yeah.
But that's the beauty of chaos theory. It reveals these hidden connections
Okay.
that we wouldn't normally see.
Okay.
Remember that physicsreport.pdf document you sent?
Uh-huh.
It actually touches on using chaos for communication,
Right.
almost like a secret code.
Yeah. Now that you mention
Yep.
it, I do remember something about that.
Okay.
It was talking about using chaos to transmit information.
That's right.
So instead of sending a clear message,
Yeah.
you would disguise it
Uh-huh.
within this chaotic stream of data
Right.
that only someone with the right key
Exactly.
can understand.
That's the idea.
Kind of like a super secret language.
You're exactly right.
Okay.
Think of a chaotic system
Uh-huh.
as this constantly shifting, complex stream of data.
Okay.
If you learn to control that chaos, you can embed information directly into it.
Wow.
So imagine you have two identical chaotic systems,
Okay.
one at the sender's end and one at the receiver's end.
Okay.
And if you can synchronize them, any changes made to the sender system would be mirrored in the receiver system.
So you're saying that by slightly tweaking the chaotic behavior
Exactly.
of one system,
Uh-huh.
you could transmit information
Yeah,
to the other system,
that's right.
which would then see
Uh-huh.
those same changes.
Exactly.
Wow. So it's like having a secret conversation
Uh-huh.
through chaos itself?
It's like a
That's wild.
perfectly synchronized dance.
Okay.
But instead of dancers, we have these complex systems mirroring each other's movements.
Okay.
And the physicsreport.pdf document also mentions something called topological entropy,
Topological entropy.
which is a way to measure how much information a chaotic system can handle.
So a system with higher topological entropy
Right.
could transmit more information.
Exactly.
It's like a bigger pipeline
Yeah, like a bigger pipeline.
for secret messages.
Exactly.
Okay.
And here's where it gets really interesting.
Okay, tell me.
Remember those chaotic saddles?
The escape hatches?
The escape hatches we
yeah.
talked about earlier.
Ah.
Well, those chaotic saddles
Yeah.
are not only fascinating.
But they also happen to be
Yeah.
very resilient to noise. And that makes them super valuable for designing communication systems that can work reliably, even when there's a lot of interference.
So it's like sending a message
ghost.
through a storm
Uh-huh.
and knowing that it will still get through intact.
That's the idea.
Wow, this is incredible.
It is pretty amazing.
We started by talking about how chaotic systems are inherently unpredictable. But now we're seeing how that very unpredictability
Exactly.
can be harnessed
Yeah.
for communication and cryptography and even creating more reliable technologies.
That's right.
My mind is officially blown.
It's pretty mind-blowing stuff.
This deep dive has been an absolute whirlwind of information.
It has.
Before we wrap things up, can we recap
Yeah.
the key takeaways
Of course.
from all three parts?
I want to make sure I'm retaining all of this.
Okay, so in part one,
Yeah.
we dove into the fundamentals of chaos theory and discovered how systems that seem random are actually governed by hidden order.
Right.
We also explored that fascinating concept of the chaos machine,
Uh-huh.
which could revolutionize cryptography
Right.
by using the power of chaos
Right.
to create incredibly secure keys and encryption methods.
And then in part two,
And in part two,
we discovered that chaos theory isn't just some abstract mathematical idea.
Right.
It's being used in all sorts of real-world applications.
That's right.
Everything from physics and astronomy to biology and even economics.
Yeah.
And then we learned about this mind-boggling concept of controlling chaos.
Yes.
Using tiny nudges to guide these unpredictable systems towards a desired outcome.
That's right.
And in this final part, we uncovered this surprising link between chaos and communication.
Exactly.
We learned how chaotic systems can be used to transmit information securely and reliably.
That's right.
Even in the presence of noise and interference.
Yeah.
And we also explored the crucial role
You did.
that chaotic saddles play
Yes.
in making these communication systems super robust.
That's right.
This has been a truly mind-expanding experience.
It has been a really interesting deep dive.
I feel like I've gained a whole new perspective on the world around me.
I'm glad.
But as you said earlier,
Yeah.
the exploration doesn't end here.
It doesn't.
There's always more to learn,
Always more.
more to discover.
That's so true.
So to keep that exploration going, here's something for you to ponder.
Okay.
Based on what we've learned today,
Okay.
how do you think our understanding of chaotic saddles
Yeah.
and their ability to withstand noise might shape the development of future communication technologies?
It's a great question.
Could we one day
Yeah.
use the power of chaos to create ultra-secure, super reliable networks that can withstand anything?
It's a really interesting thought.
The possibilities are truly limitless.
They are.
Wow, that's an incredible question to think about.
It is.
It really makes you realize how much potential there is in understanding and harnessing the power of chaos.
Absolutely.
Thanks for taking me on this incredible journey.
Oh, you're very welcome.
Until next time, keep exploring.
Yes.
Keep questioning.
Uh-huh.
And remember,
Okay.
even in chaos, there's beauty and order waiting to be discovered.
I like that.
Me too.